Hi. So I attended the Gravitational Waves and How We Hope to Observe Them lecture on November 2nd at 7 p.m. in the Kolk Undergraduate Learning Commons. And for this lecture, we had two speakers, Professor Shoemaker and Professor Catanetti. So Professor Shoemaker spoke first, and she spoke about gravitational waves and their relativity. She explained that the gravitational field only has a relative existence, and she tried to explain this by saying that if an observer is freely falling from the roof of a house, there exists no gravitational field, at least in his immediate surroundings. And instead, gravity equals acceleration. And she also introduced a formula for Einstein's general theory of relativity, and this clearly shows the principle that matter tells space-time how to curve, and curved space tells matter how to move. From Professor Shoemaker, I learned that if I wanted to age slower, that I needed to move quickly in a low gravitational field, which I thought was interesting. I didn't know that before. And next, Professor Catanetti spoke, and she spoke more about gravitational waves. She explained that they are ripples in the fabric of space-time, and they also tell us about the universe. They are strains, and they can potentially be detected by the change in length divided by the length. However, we have not been able to do this yet because they are very challenging to detect since they are so tiny, and they also travel at the speed of light. But she told us to fear not, because we are on the brink of discovering gravitational waves. She works for a company or a program called LIGO, Ligo, and they have resumed their search for gravitational waves. Their original reach was only 100 galaxies, but now with their advanced reach, they are able to see 100,000 galaxies. And she told us that a neutron star binary coalescence happened once in every 10,000 years per galaxy, and the expected detection rate order of this was 1 per month in their advanced lingo at full sensitivity. So hopefully this could enable us to actually find or detect the gravitational waves. This is a huge project. There are 60 partners from 19 different companies working for this program, and they have about 150 instruments covering at full spectrum from radio to very high energy gamma rays. So hopefully, she told us that in the next few years, they should be very interesting ones in the field of gravitational wave science, and maybe we can detect them soon. Who knows? But for me, the most interesting part was when Professor Shoemaker spoke about black holes. I've always been interested in black holes. I've always thought them to be fascinating and something I never really understood, but it's out there, and I want to learn more about it. And she used this term called spaghettification. Pretty sure it's a made-up word, but she said that this happens when, like, if you're approaching a black hole, like, feet first. Who knows if that'll actually ever happen. But if that were happening, your feet, it would pull faster at your feet than your head, so it would stretch you out like a piece of spaghetti, essentially. And I also learned that black holes actually are very common in space, and they can be seen, meaning that you can see the matter interacting with the black hole since it's consuming its partner. She also brought up the idea of a black hole collision, and I found this concept so interesting. Like, I had never heard of it before, so I actually went onto my computer and did some research about it. Yeah, I'm a little bit of a nerd, maybe. So I found out that once two black holes come so close to each other, they cannot escape each other's gravity, so they'll actually merge and become one black hole. And such an event like this would be so extremely violent that we still aren't able to, like, fully comprehend, like, the violence and what actually goes into a big collision like this. And we do know that this merger would produce such tremendous amount of energies and send massive gravitational waves through the space-time fabric of the universe. And once we are able to detect these gravitational waves, it would give us a better understanding of gravity and the physics behind black holes. So that is my little review of the lecture. I found it very interesting. And yeah, yay physics.